Hey everybody, this is Jonah Lupton, and today we have a wonderful guest. I got a chance to spend Wednesday afternoon with Rick at the Desktop Metal headquarters in Burlington, so I actually got to see all these machines in action before doing this interview, which was pretty helpful. But I'd like to introduce Rick Fulop. He is the co-founder and CEO of Desktop Metal. Rick, how are you?
Awesome, Jonah. Thanks for having me.
Absolutely. Thanks for hosting me on Wednesday. I appreciate that.
It's a pleasure.
So let's just assume that someone watching this right now doesn't know anything about Desktop Metal. Why don't you talk to us about what you guys actually do?
Yeah, so Desktop Metal is a leader in the production of systems to do additive manufacturing for mass production. Additive has been around for roughly 2 decades, but the technology was primarily focused on prototyping or jigs and fixtures or tooling. And really what we brought to the table is the ability to mass produce product at scale that was previously unavailable and really at a cost structure as competitive with conventional manufacturing. This is the fastest growing segment in our industry. And so it's very much about enabling people to go to market with additive.
No. Okay, so talk to us about the benefits of additive. I mean, I've done some research on you guys in the industry. I know Kathy Woods at ARK Investments and several other prominent investors have said they think this could be a $150 billion industry by the end of this decade. What are the 3 or 4 biggest benefits of why a company like Ford, General Motors, Boeing, I mean, you guys have all sorts of large customers lined up. Why would they use your 3D printers in their facilities rather than doing things the conventional way?
Yeah, when you make products the conventional way, you've got limitations in geometry and you have to get tooling in order to make a product cost effectively. One of the really cool things about additive is you can make anything, you have freedom of shapes without significant retooling of our production line. So there's really 4 major areas. One of them is the ability to design the product around the physics that the product's going to be exposed to. And that's using new tools like generative design, and it allows you to lightweight components and make them a lot more efficient. Another major benefit is mass customization. So the ability to make a product for you or for somebody else that is custom to what you need. In the case of dental or hearing aids, that is fantastic because everyone's ear is different and everyone's teeth are different. But in healthcare, I believe there's going to be a revolution this decade where you go from parts that are made of, let's say, 3 or 4 or 5 sizes, and a surgeon's picking what he needs in the middle of surgery, to a more of a mass customized, patient specific type of environment because everybody's body is different. So
I remember my dad had to get fit for a knee replacement years ago. I mean, this was just a sleeve, but still, it's medium, large, extra large. That's it.
That's it. Yeah.
And one's too big, one's too small, but you got to pick which one is, least painful or most annoying for you. So I get it.
Many downsides to that approach. Whereas today you've got imaging and you could build something that is, it's probably the same design, but it's basically sized to your body. And this is even more of an issue globally because I think a lot of the implants in the US are made for Caucasian models, but around the world, people have different morphologies in their body. And some people are big bone in some parts of the world. Some people are shorter, some people are taller. And it's definitely an opportunity to build patient-specific products, as well as biofabrication, which is an area of printing for healthcare that I think will become a large business this decade. So, but going back to the sort of 4 or 5 major advantages to additive. So you had the ability to design for the physics that you're going to be exposed to, the ability to mass customize. We just talked about that. There's an application called reductive decontenting, or also called assembly consolidation. And this is when you take a product that would have had 15 or 20 or 100 parts because the manufacturing process dictated that the parts are built separately and then they have to be assembled into a large unit. But with printing, you can eliminate the hardware, meaning all the screws and bolts, and then you can just print the entire product as a single part, or a major part of the product as a single part. And
that's probably similar to the bracelet that you guys showed me the other day, where normally all of those links would have to be, assembled by an individual.
Where it's just printing the entire thing. Yeah, but
continuous thing.
The example would be in an antenna, instead of having 100 parts, you have one part that has all the components, or in any type of large complex assembly, there's a lot of components that can be reduced and printed as a single part. And that has major implications to supply chain and lightweighting and performance and size of the product. And so that's a very high value add capability. There's other supply chain benefits that are major, and that's with COVID become very apparent, given all the shortages and all the other issues that people are facing. When you have additive, you have a new modality to get products around. Today, you've lived in a world that had air, land, and sea to get a product out. And if you're trying to sell something that's made in another part of the world, you have to make it somewhere else, import it, and then distribute it and pay tariffs.
If one piece of the supply chain gets messed up, it screws up your entire manufacturing flow.
That's right. Whereas with additive, you could print locally, you could send files digitally, skip tariffs, skip shipping, and then just print it locally, customize it for a particular environment, and then so you make a better product, and you print it only when you need it. And that leads to all sorts of business models where you change the cash flow cycle for some of these businesses, where particularly businesses that had to have planning, long-term planning for tooling or production, and maybe a year in advance, and you're trying to guess what's going to sell the next season. Here, you could have a much shorter cycle, similar to what the fashion industry did with fast fashion, where they're able to be more nimble and have more of what's going to sell. In this environment with additive, you could make only what people are actually buying, and make.
You don't have to worry about delays, and right now we hear about all these ships that are stuck in the ocean. They can't get into the ports. Once they get into the ports, they can't get their containers offloaded, and then the containers sit there for 2 or 3 weeks until they get picked up by truck. So, and then the whole time you're just paying extra fees and tariffs.
I mean, I had a customer yesterday that was talking to us about issues they're having that sound similar. So we've had a lot of tailwinds from so this is a new modality of manufacturing that's fully digital instead of the analog way of doing it. And then the final thing that's really exciting is really the environmental benefit of eliminating scrap and having a greener approach, because you can recycle all the materials. And in that advantage, we have our particular processes, because they print at room temperature. You can reuse the materials many more times than, but I mean many more, it's like orders of magnitude more times than processes that heat the material during printing.
Meaning lasers, right? Lasers.
Yeah. The laser process, your powder will absorb oxygen, whereas in our approach, you've got much higher recyclability and dramatically greener process. But versus machining, it's also greener, because you don't have to have all the waste that comes along with machining a part where you're throwing away a large portion of your product. So many benefits. If you look at it in a life cycle of a product, in a product life cycle, meaning you've got the upfront, which is the design. In a traditional product portfolio, you'd have a tooling phase, which you skip with additive, and then you have the production of the parts, and then in conventional production, you would pre-produce in many cases the spare parts because everything is tooled up. You don't want to tool it up 20 years later when you need the spare parts. So very large companies have warehouses that are very large, where they have spare parts that they produced when they originally made a product. And
then they stop making that product, and they have all the leftover parts.
Or they guessed wrong. Somebody made the wrong decision. They needed to make a quarter or something. They didn't make as many spare parts, or they guessed wrong. And 20 years later, there are no spare parts for that product. and it could be a tractor. It could be a construction piece of equipment. It could be a high value component in a factory. So those are other things that additive also makes better, and provides significant advantages in those areas.
Talk to us about the diversity of your portfolio. I mean, obviously the name of the company, Desktop Metal, that's essentially where you guys started, but you have obviously over the past 12 months, especially the last 6 months, really expanded your portfolio both through organic launches and then also some M&A. So I know you guys have 225 materials right now. How many different machines across your portfolio do you have?
Yeah, so we have been focusing on processes that are area-wide, high-speed mass production processes for volume manufacturing of parts at cost. In particular, at cost, it competes with conventional manufacturing. Today, we've got an industry-leading portfolio in what's called binder jetting or single-pass jetting, which is one of the processes that we use, and also on the photopolymer side. So we have over 225 qualified materials, and materials open up opportunities, right? Because you're trying to achieve a certain set of properties to enable an application. So we have the best-in-class materials portfolio for mass production, over 225 materials, and they span the gamut from metals, ceramics, photopolymers, elastomers, where we have really the best materials in the world, and
then even stuff like gold and silver, right?
Yeah, gold, silver,
stainless steel, carbon fiber. I mean,
yeah, and wood is a new thing that we launched recently with a very, very small acquisition that actually has turned out to be fantastic. I'm super excited about that work, and that effort has led to it's going way better than we ever expected. But when we acquired it, we didn't think it was. We thought it was really cool, and because it was compatible with our metal printers, we felt like this is going to add additional market for our systems. But I didn't realize that the finished good wood business is bigger than injection molding. I didn't know that.
And it's cool because when I was in your facility on Wednesday, I got to see all the different grains that you can print out.
Yeah, it's a fully digital process, and I'm wondering if I can pull up share a slide just to show you.
Yeah, I can give you screen sharing if you want. Let me know when you're ready.
Give me a second here to I'm going to have to find it, so you have to give me 2 seconds to
take your time
to pull it up. But it is an awesome product.
And where's the demand coming from? I mean, I'm sure it's all over the place, but like any industry specific, is it the architects and designers?
No, the really wonderful thing about printing is that it is an industry that is quite horizontal. I personally think it still says screen sharing.
Oh yeah.
Yeah. So let me see.
Hold on. Let me. I got to give you permission.
Not a problem.
Share all.
Are you recording?
Yeah.
Okay. Awesome. I just want to make sure I don't see the sign. The recording thing. So.
Let me know if you can share your screen right now.
I just want to make sure that you're recording. Yeah, it is recording. Okay, perfect.
Yep.
Yeah. So this is you can see some of the grain and finishes that you can achieve with this, but it's over a $1 trillion market for finished wood products, and we can achieve mechanical properties that are similar to what you get out of a tree. You can make structural furniture, and it's super sustainable because the raw material is waste. So
right, sawdust, right?
Yeah, well, basically, wood is made of two parts. One part is lignin, which is the binder that holds the tree together. The other part is cellulose, which are the matrix. And what sawdust is mostly cellulose. So we take waste from the paper manufacturing industry, which is lignin, and there's a lot of it. And then we take waste from the furniture manufacturing industry, which is the sawdust, and we inkjet one into the other and form wood parts out of it. And then by varying the color of what you inkjet, you can achieve beautiful grains, and you can biomimic pretty much any type of wood. And so what's exciting about this product is that you see the parts, and to me, I've been seeing printed parts for a long time. I was a very heavy user of additive technology before I started this company, and that kind of gave me the foundation for what we wanted to do. Being a actual user of the technology, I felt like I understood where the opportunities were. But what's really exciting is when you see a part that you can't distinguish from something you'd see in a luxury store. And you've seen our wood parts.
Phenomenal. And then even, when you see the stainless steel before and after it gets polished, after it gets polished, it looks like any high-end luxury stainless steel part that you would see in a, automobile or anywhere else. Very, very impressive.
Yeah. So it is a cool. So the wood products are I think an untapped opportunity where we don't have competition, and it's very much a blue ocean market for us.
When, like, so for all, okay, so for all of the materials, I mean, I know most of the time you guys are selling these large, either the studio machines or the production systems to clients. At any point, do you guys think you'll make products for customers in your facilities and then ship them the finished products?
So, yeah, I mean, our growth strategy is to have, and this gets into the M&A to some extent. We always do an analysis in every market that we play in, where we really try to have a good understanding of who's going to capture rent in the long run. So we want to be on print. There's many ways to print a part. There's extrusion, there's laser systems, there's laminated object manufacturing. There's many approaches. There's stereolithography. We tend to migrate to approaches that benefit from Moore's law, so that the technology gets more and more productive with time. So those are either inkjet or area-wide DLP. Area-wide DLP benefits from the chips having higher resolution, which means more parts in a bed, and the diodes that provide the polymerization, the power for the polymerization, increasing in throughput and in power density every couple of years. So our systems are on an exponential curve, and then we array that to broaden the slope of that curve. And that's proprietary patented technology that we have on DLP arrays. And then on the metal and wood and other products that are through binder jetting, we have technology that really inkjet is the limit of the throughput. And what we do in our systems, we build big arrays of inkjet to have very, very high throughput. So whereas a competitor like X1 would have a print head that only has 400 nozzles, we have print engines that we put together that have 70,000 nozzles. And that gives you extremely higher throughput. Now, what's cool about it is that the inkjet market doubles in throughput every 18 to 24 months. So as we do a new generation of hardware every couple of years, we have a continually improving economic payback of our systems, or the break even to our systems continues to get better and better and better. And so that is really the foundation of our investment in platforms. So back to your question.
Your machines are 100 times faster than
lasers. Our faster systems are 100 times faster than lasers, and obviously we're working always on generations of technology. So I think one of the things that you're going to see from our companies, we have a higher investment in R&D than our peers, and you're going to continue to see our efforts continue to pace the market. Now, back to the strategy. Would we ever make parts? So we have in our slides, if I put this up, a growth strategy. Let me try to find the right slide for you. And here we go. So we have this thing we've coined, we call additive manufacturing 2.0. Yep. And now other people have tried to glom onto that term, which is fine. What we think of additive manufacturing 2.0 is the ability to manufacture products cheaper than conventional manufacturing at scale. So it's not making tooling. It's not trying to make a cheaper product than some legacy thing like Stratasys, and you're just trying to make kind of clones of those products. It's not making very high-end, super slow things that end up in a rocket. It's really about mass production with additive and making it a common manufacturing technique. So we have three pillars of that strategy. One is to have state-of-the-art processes that are AM 2.0 that give you throughput at scale. The second part of that strategy is to be vertically integrated into the consumables, which happen to be high margin. So these printers consume ink or consume other materials, just like
when you say high margin, you mean over 50%, correct?
Definitely, yeah. So that gives you the ability to build a high margin recurring revenue stream. And then finally, on the part side, we think about it with a lens of killer apps. So in our business, there are several killer apps for additive. One is printed elastomers with lattices. So these are metamaterials that allow you to make a digital foam, and that's a fantastic business. There we acquired a company called Adaptive 3D, and that's something that we have high hopes for. I think it's going to do extremely well. And we sell those materials with our printers. On the part side, all the killer apps are dental, where there's incredible growth, or healthcare applications where you get much higher value for the part than for the print technology. And a good analogy of that would be, we look at it with a lens of hearing aids or align technologies. So aligners are today primarily manufactured with additive technology. It is a big market for photopolymer printers. And we have major companies like Align and Smile Direct have been customers of our company. The point I'm trying to make is, if you look at a market like hearing aids, pretty much all the world's hearing aids, the shells, which are printed today, could be made with less than 200 printers. So the challenge there is that you have a market and the value is not being captured by the print manufacturer, it's being captured by a third party. And when you look at applications like biofabrication, which is a novel nascent market that is just in the germination stage in the healthcare side, or some other particular segments, you may want to be a producer of parts for the industry instead of a producer of, and the industry actually wants you to do that in many cases. So there are some applications where you could provide parts and customize the manufacturing technology. We do that very selectively, but there are killer apps where you want to really capture that value. So we do that. We obviously don't want to compete with our customers, but we have a state-of-the-art, best-in-class print process business, making printers and selling printers. We've got vertical integration in as many of the materials as possible that we can. We also work with partners where they have unique technology that adds value. And then on the part side, it's very much about killer apps and special applications where we can change the game for customers and enable new things that weren't doable before, and where we can capture the rent. So that's our growth strategy. And some of the M&A activities that we've got have been centered around gaining new capabilities to enable that strategy.
Do you think you'll do more M&A in the future?
I think so. We have, just shy of $600 million in the bank today. So and we have a background. One of the things that's unique here is we have a company where several folks in the senior management team have a background making money as investors before they were entrepreneurs again. So me included. So I think we will get a very good return on this capital. Some of the moves may turn heads and may be hard to understand at first. For example, forest. If somebody told us we didn't spend a lot of money on forest. It cost us around $2 million to acquire the technology. And when it was developed by a very sharp fellow named Andy Jeffrey, and then two professors in California, including the chair of the architecture department. And when I first saw it, I wouldn't leave the meeting till we had a handshake. But we paid, all the numbers are on the filings, but we paid like $2 million or something like that for a technology. At the time, it was quite immature. It needed a lot of work to get it to what it is today. But the IP and the know-how and the technology was there at the time. And if you asked a Wall Street analyst or somebody else at that time, what do you think of what we're doing here? They'll say, why don't you just focus on your metal business? And but we felt like this was something that could amplify our metal business because it uses the same machines and it's just another material in the arsenal. However, it's one without competition in a massive market and where you could do something no one else has done before, which is something we like. It's enabling new applications at scale for mass production. So that, we did it and actually technically it worked. And I think that's going to be a very large business for us in the future. So that's an example of getting a new capability that we didn't have before, where we get vertical integration into the materials and it has all sorts of benefits down the line.
So you talked about cash in the bank. Most of that cash came from the pipe, right? So you guys were a SPAC. You came public last year with the SPAC. You raised, I think it was a $275 million pipe And four of the investors are probably four of the best investors over the last couple of decades. So you have Ron Barron from Barron Capital, you have Bill Miller, been around for 30 or 40 years, early Amazon investor. You have Chamath from Social Capital, and then you have JB, who was one of the co-founders of Tesla.
That's right.
So maybe just spend a couple minutes talking about how you got those four prominent investors into the pipe.
Yeah, I've known JB for a long time, and since well before I started this company, and then I think we also have a great sponsor in Leo Hendry, who did TCI, sold it for $56 billion to AT&T, and essentially consolidated the cable industry. So he, by the way, is fantastic, and he's on our board, and we worked very hard to explain to people why this was going to be a massive opportunity in an industry that's going from 12 billion to 150 plus billion this decade, and why we can be the winner in this industry. So I think we're very excited and lucky to have the support of a fantastic investor base, as well as the investor base that we had before we went public. We had some of the largest companies, BMW and Ford and Koch Industries and Google, and some of the best venture capital firms in the world, like Kleiner Perkins and NEA and Lux Capital, which is a spectacular venture capital firm. So very good investor base.
What industry? So just taking the metal composites, what is it? Autos? You think that gives you the biggest total addressable market?
Well, what I love about this market is that it's very horizontal. I don't like account concentration. It doesn't build great businesses. You want to have a diversified customer base where you have no account concentration. So automotive for us is around 20%, and that includes the tier ones. And I want to build a business that keeps it at that rate. And so we've got many other markets, from jewelry to consumer goods to consumer electronics to defense, aerospace, and it's the same machine being used for multiple applications. That's one of the benefits of having lots of materials qualified for your platform, is that you've got lots of applications for the same hardware, and you get scale that way. So
now the machine, now you're using a virtual background. Is that the P1 behind you?
That's a P50.
P50. Okay. What's the lead time on the P50?
Well, right now we've got a huge order book ahead of us. So you if you didn't put a deposit or were in line before the pandemic, you're not going to get it this year. But we have a reasonably large order book here, and I think we're very excited about this product. It's the fastest metal printer in the world, and it's it got game-changing economics. It's about a quarter of the price for unit volume of any of our competitive processes right now. So.
And I've seen the projections, over a 10-year period, which is kind of the life of the machine, you would expect to make, 3 or 4 times in consumables that you.
Yeah, it varies by product. So we have products like our photopolymer systems, where the metrics are let's say our fastest product in the photopolymer space is the Extreme 8K. It's the fastest printer in its category, and it sells for about $150,000. A product like that will generate about $1.6 million over the life of that product. So it's significant revenue on a $150,000 sale, of which 112 comes to us. So it is a very good setup, and that's over 7 years. So it's 14 times the upfront revenue over a 7-year life cycle. A P50, on the other hand, is a product where we are only selling the ink. We're not selling the powder that flows through the machine. If we sold the powder, the units economics would be much better. But today, they're still fantastic. A $2 million upfront sale will generate $6.5 million over the life of the product. So 2.5 upfront generates 10-year lifetime total gross profit of 3.8, 6.5 of revenue, and that's also high margin. So
gotcha. Now, who do they buy the materials from?
So they buy the ink and several of the other consumables from us, and then the powder is a commodity today. There's many companies that make metal powder, but that machine, consumes 0.5 metric ton of metal powder per hour. So it's, we've talked when we're in public of eventually vertically integrating into it, because the settings and all the parameters and all the process that you do to optimize the process for a particular powder is like a lottery ticket for one of the powder producers. When if we qualify an alloy with a particular producer, ship a machine, I mean, that's like a payola for those.
Oh, for sure, for them.
So, because then the customer would need to requalify a different supplier, and that takes time and process development. So the benefit of eventually being vertically integrated is significant, in particular if you can vertically integrate yourself into a process that has a better yield than the current approach. So today, the powder industry in powder metallurgy uses a technique called gas atomization for AM powders, and that is relatively expensive, and it produces a very wide distribution of powder, of which only a small portion is usable for additive. So the cost of that powder is expensive, and there are some newer techniques that give you higher efficiency, and that is pretty exciting. So,
gotcha. Okay. So there's multiple suppliers of these powders that you guys are essentially approving.
Dozens of suppliers in this area.
I'm trying to think what else. I think I pretty much covered everything that I wanted to. We talked a little bit about some of the competitors. I know two of the names that there's a few names. There's 3D, there's Stratus, there's Mark Forged. I think you already spent some time talking about the differentiation between you guys and them. Anything else that you wanted to mention?
No, I mean, I'm excited about where we're going. We've got a massive opportunity to build a huge compounding security here. We're growing faster than any of our peers in this market, and it's going to be a 11x growth from where we started to where we're going end of this decade. So
if additive manufacturing gets to 150 billion by the end of the decade, and you could certainly surpass that number. I mean,
it's still only 1% of global manufacturing. Right. So this should be like a double-digit number. So in our lifetime, I'm convinced that I'll see that, and so we have here a long arc opportunity. This is like investing in semiconductors in the 70s, right? So our goal as a company, everything we're doing is to, we had set out a target to be $1 billion in 5 years in revenue, and we have a plan to achieve that. And our goal is, everything we do is to pull that in. And my vision is to end this decade with double-digit percentage of share in our market.
I was just going to ask, what do you think that you can capture in terms of market share by the end of the decade? So
I think in our part combining materials, printers, and parts, we can be a double-digit percentage of this market.
Cool. Well, Rick, thank you so much, man. I really appreciate your time, both today in the interview and then on Wednesday in the tour. Love to have you come back in a couple months, and we can talk about those Q2 earnings or Q3, awesome, whenever you think the right time to come back might be.
I love it. Thank you very much. And again, congrats on everything going on in your world. So thank you very much.
I appreciate it. Look forward to staying in touch.
All righty. Talk to you soon.
Have a good one.
Yeah.
Bye-bye.